Thank you. Thanks to everyone for coming today. I'm Adrian Thomas. I'm going to be talking today about some of the web application vulnerabilities to look for when you're developing applications, or web applications. So, like I said, I'm Adrian Thomas. I'm the development team lead at CAP Automotive. Enjoy coding, playing with cars. But yeah, we're leaders in providing valuation data to the automotive sector in the UK. So that's a range of vehicles really, cars, bikes. I think we even do jet skis and so HGVs, so pretty much any vehicle. And we sell that data as well to dealers, insurance companies, finance, pretty much anyone who wants it.
So it's you, is it?
It's me. It's me. Yeah, our IT department's expanding quite a lot as well. So if you're interested in any roles, I guess speak to the guys here. There's permie and contract positions available. And that's me at Cadswell the other week as well. I had to get that on snuck in. Yeah, that was the smart car which actually overtook me further down the road. So it's a bit of a shame, but yeah, it was pretty quick. Yeah, it was a Brabus. It had been tuned as well. So yeah. So the talk's about well, like I say, I'm team lead. Background software development. We often learn about new tools, new technologies, and how we can generally be more productive, make our lives easier to write software quicker. We don't often learn about the security implications of maybe using certain libraries, frameworks, and these frameworks often do provide basic guidance and protection usually by default. But obviously, we have to, as developers, we have to make customizations, and that's kind of where the security issues start to come into play. So pretty much this talk's for anyone involved in software development. It's probably more focused towards developers, because I'm a developer myself, so I've kind of focused on what aspects I found interesting. But it really is for anyone who's involved in software development. So there's a few areas really why you should be interested in this. Your business being broken into could be catastrophic, but also your customers' experience as well, the image of the company. All these things can be detrimental if under these circumstances. And so basically this talk will cover some of the things to look for. A lot of it's based on, I don't know if anyone's read much of the OWASP top 10. That's a good guide to look through. I'll be covering about 5 of those today just due to the time constraints we have. First one, injection, of course. I'll cover questions at the end as well if anyone has anything to cover, because like I say, it'll take about 30 minutes anyway. So yeah, injection. So everyone's probably quite familiar with SQL injection anyway, but there can be other aspects to it as well. Basically anywhere a query or command is passed into some kind of interpreter. And if that's executed without, well, the process of passing in that untrusted input into that interpreter could potentially give someone the ability to execute a command without authorization.
Come on. Something went out.
So like I say, we so yeah, we often think of SQL injection, but there's you could have susceptible to LDAP injection, operating systems, so command line, PowerShell, XPath, NoSQL, XML parsers, anywhere really. So here's a little snippet of example code. So you can see that we're simply passing in a folder name here, and we're building up a command just to list a directory structure, and then we're going to execute that command. So an example here is we might have just, as part of the URL, we might accept pictures as the name of the folder. But if we change that to something else, then maybe we put a space in there and an ampersand, and then we send it a shutdown command, force it to shut down, and then you could potentially shut down that machine that the web application is running on. And like I said, that could potentially knock the website offline. So the impact could be catastrophic. In that example, it probably isn't just shutting it down. But if you do have full command line control, then obviously that's quite bad. And it could also be a gateway for other attacks as well, to possibly other systems internally, which aren't usually accessible either. Well, it can be prevented. You can use a parameterized API that doesn't just accept untrusted input, like we saw in the previous example. We could have a blacklist of characters. So in the previous example, we had an ampersand, which allowed you to run another commands in the command line. But a better option is obviously a whitelist, where if we're only expecting characters from A to Z, 0 to 9, then we're probably best just blocking everything other than those characters there. I chose this one because I liked it.
Is that a file?
I don't know. I'll have to ask him next time. So bump into the pub.
Stick up, Harry.
So the second one's authentication hijacking. So often authentication or session management is not implemented correctly. Passwords or tokens can be discovered and used by attackers to assume another's identity. And there's many areas that could be vulnerable, so password management, timeouts, secret questions, account updates. Common targets are privileged accounts, so access other parts of the system. There's several ways to be vulnerable. So obviously credentials not being encrypted. If any kind of tokens are explained in as plain text. Tokens that don't time out, and others. So one example we've got here is we're maybe accessing some kind of API, and we're passing in an authorization token as part of the URL. Even where we're over HTTPS here, it's obviously as part of the URL, it's still not encrypted, that token at that point. What's worse is this is just encoded as base 64, so we could just reverse that anyway and then find out the username and password. It's probably a bit of an extreme example. But, so yeah, in this example, if someone sent this URL or posted it online or something, then at that point anyone will be able to access this person's pictures that they've set up there, because they would also be showing their authorization. So it can be prevented. Well, there's not a single solution to all problems. It depends on the problem. Sticking to a tried and trusted framework's quickest and easiest, but this kind of goes back to what I was saying about we often have to make customizations anyway as developers. It's kind of our job, isn't it? One of the things OWASP recommends is their application security verification standard. It's a nice big document which I didn't take the time to read through because it is pretty hefty, but if you are developing any kind of custom authentication, then it's well worth a little look through. So the next one is cross-site scripting. So this is the most widespread one seen. It's typically when an attacker sends untrusted data to an application, and when the same data is represented in the same form to other users, it represents a cross-site scripting attack. And yeah, in effect, what it's doing is it's allowing an attacker to execute JavaScript on another person's machine. Obviously, if that JavaScript was running on your website and you were maybe storing something in a cookie, another bad example maybe, but a username and password in a cookie. At that point, if you can execute the JavaScript on the website, you could potentially send that cookie and the username and password details anywhere you liked to an attacker's site, for example. So there's 3 types of cross-site scripting attacks. And as persisted, this is where the script is actually stored, well, the backing store of the application itself. And I'll give examples of these in a moment. We've got reflected. This is where it's sent to the web server and it's reflected back to the user's browser, but it's not actually stored. And then we've got DOM-based as well, which is very similar to reflected, except that no JavaScript or code is sent to the web service, or to the web application, its backend. It's all in the browser. So a persisted attack is an example is if an attacker visited a social network site and they post some JavaScript on a comment against the post. The application would store the JavaScript and store it as a comment in the database. And then if another visitor came to the site at that point and they would see that comment, then it would execute the JavaScript the attacker placed. And the victim would be none the wiser, and they might try to post a comment against that post. And they might be prompted with a username and password prompt. It might be the exact same one they're used to seeing on that website normally, but they wouldn't know any different because it's just the JavaScript being executed directly. Yeah, and potentially because that malicious JavaScript could then send their credentials to the attacker's website, web service, or email it to the attacker and whatnot. Reflected attack. So an attacker could send a URL to a user, and that person clicks on that link. So a typical one we might see is some kind of product search for jeans. That's a typical query string we'd see. But what if they sent something a bit, something else? So obviously that's just a little alert there, but obviously there could be something more substantial there. and that script we returned back on the web page as well and executed. So often if you do a search in a web application, you'll make the submission, it'll say you searched for, and then whatever you searched for. If you're returning exactly the same data that was input, then that presents a cross-site scripting attack. And there's an example there, so you'd see you searched for, and then the script that was rendered. And again, they could send the content to the cookie or something like that. Maybe the cookie would store session data that could be sent and possibly used by an attacker. And then we've got a DOM-based attack. So again, it's a very similar process, but we might have an example of where we've already loaded all these products into the web page, and changing the query string just changes the paging all client side. So again, you could insert scripts there and nothing would necessarily be sent back to the website, but it would still be executed on the local browser. So how can it be prevented? Well, making sure the data's escaped. Don't simply just trust the data as it is. We could also prepare a whitelist or a blacklist for valid data input. If you know what you're expecting to get, if it is just text, then it's probably unnecessary to accept other characters. There's a content security policy to protect the entire site. It's available on more modern browsers, but if you're working with any of the older browsers, it won't quite work for you. And it'll disable various browser features. So any inline JavaScript, if there's certain DOM events and attributes, will execute the JavaScript. We can also build a whitelist of external JavaScript files that we want to allow to execute in our web page. And there's many other features as well. There's quite a lot. I've not covered them all there. So the next one is insecure direct object references. And this is where an internal implementation is exposed publicly to an end user. So an example of this you might have seen is like primary keys and that kind of things exposed as part of the query string. But it can also be a file name, something along those lines. And so if you were simply changing that ID or the file name, you might be able to access things you weren't actually supposed to be able to access. So in the case of an ID, it might be an order, or so you might be able to see someone else's contact details, that kind of stuff. Or with a file name, it could be maybe if you're uploading pictures or something like that, and you change the URL to be a different name of a picture, it might show up another user's picture, that kind of stuff. And yeah, I've kind of covered that there as well. So yeah, order details, you might be able to change the ID to something else. Same with the picture there. You might be able to view something you're not supposed to. So how can it be prevented? Well, you can check if the user actually has access to those resources before you return the data. That's, yeah, does this guy have access to some file? Another way of getting around it is you can have you could build up a list of IDs or of some sort which map to the actual IDs. So we could generate some, you could generate some GUIDs for that user, perhaps, which then maps to the primary key in the database or the actual file name. So the final one I'm going to cover today is security misconfiguration. So this generally refers to the entire stack, just making sure it's configured correctly. It could be from sysadmins, but it could also be devs. Like I was saying earlier, a lot of frameworks and systems tend to have secure defaults.
This
but
way devs can blame IT.
You could try. Yeah.
Cool.
So, yeah, generally settings on new stuff tend to have safe defaults, but if there are any default accounts that have been set up that would allow just anyone to connect to your, well, it depends on what you're using, but you might have some kind of CMS system with a default account which is installed as default, and you might need to disable that. So there's a few areas that are susceptible, so out-of-date software, libraries and frameworks, unused features, any open ports for services that aren't used, like I mentioned, accounts, default accounts, yeah. Exposing stack traces, any of that kind of stuff that possibly provides a bit too much information to expose to the end user. Again, like I say, if you're exposing stack traces, then you're possibly giving clues to an attacker on how they can further break into your system. So yeah, you might have a CMS system with a default username and password. Maybe they install that as default as part of a demo experience, but obviously you don't want to leave that on a live system. So how can it be prevented? Well, ideally, it'd be having a repeatable, automated process for the creation of a secure environment. So if you had a dev staging or production environment, you'd have identical configuration. If you noticed any issues, then it'd just be a case of updating the scripts so that any new environments you needed to provision would have the correct configuration, and you could do that consistently as well. However, yeah, obviously have different passwords for the environments. Make sure your software and libraries are up to date. On the library side, I think most people often use NuGet now anyway for keeping that up to date. It's also obviously another good reason to use up-to-date libraries and tech. There's also some software available for frequent scanning and auditing, just to make sure that all your software is up to date, and any configuration could be automated as an early warning before an attacker actually does get in. So yeah, you learned about some of the top web application security flaws. Like I said, there are more. If you look up the OWASP top 10, I really highly recommend looking through it because it's really interesting. And there are some other good ones in the top 10. So yeah, I mentioned injection, which bear in mind it's not always SQL injection we need to look for. Authentication hijacking, which could be obviously be someone stealing an authentication token of some sort. Cross-site scripting, where an attacker is placing a malicious script on a victim's machine in some way, or running it in the browser even. Insecure direct object references, again exposing primary keys, file names, that kind of stuff. And security misconfiguration, which is what we just covered. Like I said, there's more. I'd look up OWASP's top 10 when you get a chance. Their last one was 2013. I think they release one every 3 or 4 years. I think the one before that was fairly similar. I think injection's been at the top of there for a while. And yeah, hopefully everyone's a bit clearer now on some of the stuff to look for when developing applications. I know it's not always the thing which we often think about when learning about new tech, but hopefully people are a bit more aware of some of the stuff to look for now anyway. Again, yeah.